Hi everyone, my name is Mala and I'm the former Director of Tech for Social Good at the software company GitHub. I also have a decade of experience working for various specialized agencies of the United Nations. In this video, I'm covering challenges and opportunities of using AI to advance the Sustainable Development Goals. Unlike some of my other videos, this video does require at least a basic knowledge of AI. As always, I have a few disclaimers. First, the opinions expressed in this video are strictly my personal views, not that of current, past, or future employers. Second, this video is strictly for informational purposes. And third, AI tooling, models, and markets are changing pretty much daily, and therefore some of what I say may be outdated by the time you view this. Alright, so let's get started. So if you're struggling to use AI to help achieve the SDGs, you're not alone. While there are a ton of examples of using AI to achieve a social good more broadly, things get more complicated specifically when it comes to applying AI to the SDGs. Why is that? I think the biggest challenge is taking technologies that have mostly been developed for narrow use cases and applying them to big societal issues. Andrew Ng, the co-founder of Google Brain, describes the utility of AI like this. Imagine you created an AI application to optimize routes for shipping companies. Your application accounts for water currents, weather patterns, and so much more. You're focused on improving efficiency and safety since those are the two biggest factors in helping shipping companies save money. There's a ton of data to feed into your application to optimize models for this one narrow use case. Now let's say you can demonstrate that your application can save a shipping company just 1% of their $1 billion annual total costs. You therefore save them $10 million per year. So even if it costs $1 million to set up, customize, and maintain the application for them, they still get a great return on their investment. We're seeing the same idea, applying AI for narrow use cases when using AI for good. One common example is using an AI technology called computer vision to identify specific types of tumors. Computer vision can detect things the human eye cannot, like microscopic growth changes or detection of cancer cells elsewhere in the body. It's able to do this because there's a lot of data to train a model, humans who can cross-check results, and of course, a narrow question, in this case, is there a tumor, that can be classified as yes or no. So computer vision can detect if there is a tumor. But what about why there is or how to treat the tumor? This is much harder, for that would require analysis of not only the individual patient's medical history, genetics, and behavior, but also the broader health system and their social determinants of health, like infrastructure, pollution, and more. Let's look at SDG 3, which is to ensure healthy lives and promote well-being for all at all ages. Now, the most granular level of the SDGs are indicators, which look at things like death rates and incidences of disease. These are expressed as absolute numbers or portions of a population. Some of the same AI technologies applied to medical health, like detecting a tumor in an individual patient, can be applied in public health to calculate these indicators or to tell us if a geographic area is more likely to have a higher disease burden. AI can therefore be extremely useful at the indicator level of the SDGs. However, once we move up to the target and goal levels, we are then tasked with why these indicators are where they are and how to make them better. And this is where things get complicated. Let's say we build a tuberculosis diagnosis computer vision model that improves the accuracy of the diagnosis at the hospital level. But then we find out to make any real progress towards the target, the correct intervention must be administered at the local health clinic. If local health clinics don't have adequate resources or medical personnel to use the computer vision model or to treat the patient, the target won't be achieved. There must be policy, budgetary, and personnel changes for that to happen. And in fact, as we've seen with the implementation of other emerging technologies in public health, a more accurate system of diagnosis can make it appear as though cases are rising and therefore the SDG target is getting worse. So one major challenge that many organizations, companies, governments, and individuals are dealing with is how to effectively use AI technologies that have mostly been developed for narrow use cases and apply it to bettering these complex problems in public health, or food security, or education, or whatever the thematic area. In these relatively early days of AI, there is therefore a lot of debate when the costs to get started are high, but the opportunities lost by not getting started could be worse. Earlier this month, I had an interesting conversation with my colleague, Bill Weeks, who is currently Microsoft's Director of AI for Health, about a classic challenge when applying complex technologies to the SDGs: trade-offs. We spoke about something called AUC, which stands for Area Under the Rock Curve. A good place to read about AUC is Google Developer Docs on machine learning, shown here. AUC is a measurement of machine learning classification performance. Going back to our same example, let's say we refine our computer vision model until we've done everything possible to optimize its performance. We can then plot the thresholds between false positives and true positives and draw a line connecting those points. Everything below the curve is our AUC, and the higher the AUC, the better the classification performance, which in this case is the accuracy of tuberculosis diagnoses. The challenge Bill and I discussed is what if the AUC is only marginally better than what we could have done without the computer vision model, especially in places where data quality and data availability are low, and therefore our model refinement ability is limited. This is a real trade-off to consider for several reasons. First is the energy load. Running an AI model, tool, or application takes a lot more energy than other technologies, which can use up precious electricity in areas that don't have universal electrification. We must also consider the longer-term effects on greenhouse gas emissions and climate change. What if our computer vision model consumes so much energy that it worsens SDG target 17.7, which is the dissemination and diffusion of environmentally sound technologies to developing countries, or SDG 12, which is to ensure sustainable consumption and production patterns, or SDG 13, which is to take urgent action to combat climate change and its impacts. Second, of course, is the human factor. For decades, we've had to consider how any technology that automates things humans do may take away limited job opportunities in economically depressed areas. If net labor is lost, we may ultimately worsen progress to SDG 8, which is to promote sustained and inclusive economic growth and full and productive employment for all. On the other hand, AI will likely play an increasingly large role in the global economy in the coming decades, and those without skills to compete may be left behind. Much of the work I did at GitHub focused on this question as it related to SDG 9, which looks at fostering innovation. Using emerging technologies to address the problems that real people face in their communities is an effective way to upskill a population. So, applying AI technologies to create marginally better solutions than what we already have may be justified if it means a more inclusive, more diverse, and more globally skilled workforce that can meaningfully work with AI technologies. Again, these trade-offs are complicated and go way beyond the scope of the narrow AI solution we build. But that's how it goes. When it comes to progress of the SDGs, we must consider so much more than the tech solution. Now that I've spoken about challenges, I want to talk about opportunities. The first is around interdependencies of SDGs. Now, of course, everything is connected, yet specialized agencies of the UN, INGOs, private sector companies, and even governments tend to look at SDGs as standalone goals because that's how funding is allocated. Instead, we could leverage the power of AI to look at the goals much like software developers look at code, as dependencies. My same colleague Bill has proposed one way this could be framed for public health based on Bronfenbrenner's ecologic systems theory, seen here. In this framing, SDG 3, good health and well-being, sits in the middle, and other SDGs are shown in different tiers. The framework proposes looking at investments in other SDGs to see their effect on achieving SDG 3. Now, of course, the volume of data required to model these dependencies is massive. After all, there are 231 unique SDG indicators. If you multiply that by the number of low and middle income countries, which, depending on the source, is 132 or 137, and then you account for the results of every documented study or program or intervention for these countries and indicators, plus other relevant external indices like GDP and income distributions, you get a lot of data. Using traditional statistical analyses to find dependencies among these data points can be very hard, if not impossible. Instead, it's possible to classify and code findings from papers, blogs, studies, surveys, and a multitude of other sources to model these complex relationships with AI. One way to do this is with deep learning, neural networks, and large language models. If the models are open source, it would be possible to adjust weights to account for different geographic, socioeconomic, or other factors. And the outputs could also be multilingual. As I mentioned in a previous video, the large language model Bloom was trained in 40 plus spoken languages. One thing to note is this exercise doesn't need to be comprehensive. In the international community, there's a tendency to take an overwhelming multi-stakeholder approach, which can slow or even stop efforts because coordination becomes unsustainable. Instead, as costs to use and customize large language models come down and low or no code interfaces for creating neural networks become more intuitive to use, it's possible that organizations run these kind of exercises on their own to ensure programmatic efforts and funding are best placed. Of course, international cooperation is important. After all, without it, we wouldn't even have the MDGs or the SDGs. Now, as we come to the final years of the SDGs, I think AI could have an important role in deciding what comes next. Currently, most low and middle income countries are not on track to achieve most of the SDGs. And while some people argue that the SDGs were purposely created to be aspirational, I do think more ground truthing could be done with private sector data. As I spoke about many times while I was at GitHub, most of the global population is now officially connected online and uses products like WhatsApp to send messages, GitHub to write and store code, Instagram to share stories, and WorldRemit to send money, and so on. For this reason, while I was at GitHub, I launched a standardized metrics project to help international development practitioners use aggregated GitHub user data to inform their programs. That supported the launch of the GitHub Innovation Graph, seen here, which allows people to explore these aggregated metrics. Now, of course, heavier consideration of private sector data to define the next iteration of the SDGs will undoubtedly be very tricky. And much like defining SDG dependencies, there's a lot that can be done with AI technologies, like with deep learning and neural networks. All right, these days it's hard to address anything about AI without talking about Gen AI. Now, there's been a lot of media attention on Gen AI because no code tools like ChatGPT are targeted to individual consumers. This is unlike a lot of other AI tools or models that are mostly code, don't have a graphical user interface, or GUI for short, and are B2B, and therefore are hard for individuals like journalists to test. Gen AI tools have also taken a lot of media attention because already they are automating tasks in writing, graphic design, video editing, voice acting, and so much more. So the media attention is perfectly reasonable and understandable. It may, however, be a little overhyped. So do I think Gen AI has a role to play in furthering the SDGs? Of course, but not on its own. The best way I can describe the utility of Gen AI is like a coded prototype versus a picture prototype. To create a high-fidelity picture prototype, you need a highly skilled person to use a powerful tool like Figma. The picture prototype adds a lot of value because it demonstrates new concepts and interactions, it can showcase a final visual design, and it can lead a user through a new primary workflow. But the real value of a picture prototype is when it's converted into code so we can interact with the actual software, website, or whatever is being built. That's how I see Gen AI. While Gen AI tools are powerful and take a lot of skill to use well, Gen AI is quickly becoming that GUI, that user interface, that us non-coding people use to interact with something much more powerful underneath. On its own, it's unlikely that ChatGPT or other Gen AI tools will produce anything accurate or relevant about the SDGs for a given country or context, no matter how much I refine my prompt. I need to do some combination of creating a database of relevant knowledge products, creating a large language model, or creating a neural network so that my Gen AI tool will then allow me to interact with all of that powerful stuff underneath much more easily. All right, well, that's it for me on the topic of AI and the SDGs. Before I leave, I want to throw in a quick reminder that I'm searching for a job. So if you're interested in hiring me, please reach out at authormala@gmail.com or on LinkedIn. You can find more about my work at malakumar.com. And of course, if you like this video, please be sure to like and subscribe for more. Thanks for watching.